to the customer. There is already most of the time historical data, and we have to play with this data to solve the problem or to reach the goal that the customer has in mind. And we have to do hybrid modeling. Why? Because you can see on the slide here, there are, I would say, some advantages and drawbacks for data-driven modeling and science-based modeling, I will call that. So science-based modeling for me is mostly based on physical balances like mass balance, energy balance, and so on. And the idea is to, I would say, to take the best part from both approaches to provide a solution to the customer. So it's not AI to do AI, it's just AI to solve a problem. And we have for the customer to get a return on investment. So the idea is to have in mind the possibilities provided by the data and the number of hours we have to spend on this project. And so in that case, you can see on the slide that with the data-driven modeling, so I will include into this statistical regression, machine learning, and so on, you need a large volume of data, but you can have quick results without deep expertise. You don't have to forget that it's mostly pure mathematics and there's no real physics included. And so you have to get expertise at minima to understand the solutions that are provided. It's not always easy to understand the solution because it's most of the time like kind of black box modeling, meaning that you have inputs and outputs, and the model will, I would say, translate inputs to outputs, and you will use that. And so it's not always explainable, and that can be a challenge regarding, I would say, decision support in industry, because the operators, they want to understand when they have to follow, when they have to do. On the other side, you have, I would say, white box modeling. So you will explain everything about everything. You need a reasonable amount of data, maybe less most of the time than for data-driven modeling. You need expertise because you will write mass balance, energy balance. It's time consuming because it's close to fundamental research. In fact, it's close to academic world. And but physical balances will imply robustness because it's understandable. And parameters have a sense in that case, have a meaning. And you can easily translate that to time series, which is not always the easy, I would say, with just data-driven modeling. And so we have to play with that. And for each project, we have to analyze data from the customer, and we have to get to choose if we want to model with physical balances, if it's possible, and if we have to complete with data-driven modeling. And if we want to go online to obtain a digital twin, we have to use anyway machine learning and so on, because you can have a model which will describe with nice curves on measurements offline, an offline model. But when you are online, you have also to identify the situation you're in, and then you need to use machine learning. And that's in that case, hybridization is really mandatory, I would say, if you want to go online. So I think I'm good. I don't know if it's okay for you. But just to say that we are in line, even if we are not always in the same domain or directly in the same domain.
Thank you very much, Caroline and Bob. And actually, maybe while people think of questions, we have now more or less 10 minutes to exchange on this, but maybe just jumping on what you just said about models or fields to the bricks that you intend to develop. That's a question to both of you, actually. We were speaking about the field of additive manufacturing, but are there other fields of application for the envisaged scientific bricks for this challenge?
Caroline, you...
Yeah, I just want to precise that most of the bricks that will be developed for the AM challenge yeah, we are targeting really generic and I would say non-intrusive approaches. So yes, they could be transferred and applied to other application domains. So of course, for example, here we will focus on AM process, but we expect that the developed technologies will be also effective for other for other AM application, because here the AM application is in metallic AM process, but it could be also applied to composite or ceramics, but also to other manufacturing modeling, I think. But yeah, perhaps for the really the physics-informed neural network. So when we want to really include some scientific knowledge into the neural network training, of course, like some expertise and knowledge, as Bob said, for the science-based modeling. Yeah, some expertise is really mandatory. So yeah, some parts of the development will be adapted to be used on other application, but yes, yeah, the different bricks could be applied to other fields that use simulation data and experimental data, because really the idea is to try to fuse and take the best of each world. Yeah. I don't know, Bob, if you want to complete.
But that's the same for me. And so when we are into the like I said, Teknor is an industrial integrator, and it means that we have as customers, we have pharmaceutical companies, we have cement companies, we have environmental companies, we have agro-food companies, and so in every project we have to absorb a part of the expertise to get something relevant at the end with the modeling. And so even if we have, for example, let's say we have a reference in cement industry, we have developed a model for a specific cement production site where there is a specific historical past about data, about practice, and so on. And so even if we go, I would say, on another side from the same company, we will have to adapt the modeling, because the sensors are not the same at the same place. The guys from the site will not drive the process in the same way, because some steps in equipments are maybe different. And so we are already challenged, I would say, in that case. And even when we write, I would say, mass or energy balance, we have to adapt these equations, even if we have the backbone already written from the previous project. Why? Because some parameters maybe cannot be identified with the data that we have from the other side. And so we have to adapt the formulation of these equations. And then we have to adapt also the machine learning hyperparameters, because the data are different, slightly different, or maybe strongly different. And then you have to adapt, even if you have, I would say, the basis in mind about the modeling. Every time you have to adapt, because for each project, the data sets are different, even in the same company, even on the same site, from a kiln to another kiln, and so on and so on. And so there is always this, I would say, brainware to bring, in fact. And so if we want to, I would say, provide something relevant, we have to blend data-driven and science-based, because we're totally dependent on the data. And so that's also the challenge, because it's always new in some way.
Benoit?
Yes, I have a generic question. So when in the past we were mainly relying on model, as you developed, Bob, and then now with the big data and the AI model, we are more and more using a mix of the two. In some sense, using a model is very good because you can explain the things, you can optimize some very precise parameters, but a model is generally just an approximation. Do you observe in some case that using AI brings you to revisit the model and to say the model is too approximative, I have to suppress this model because the coherency between the AI approach and the modeling is showing that the models that we were currently using were not good or were failing in some sense. So what I would like to see and to develop, and it may be an intuition, it's that the two sides, the black box sides and the white box sides, could maybe evolve jointly and to have an evolution and to have a cooperative learning between the two, and saying this model is failing in that situation, that particular situation. So we have to revisit the model because the AI showed some incoherency in the hybrid approach. So I would like to expand a little bit this aspect.
It can, yeah, that's, you're totally right, because even if you have, I would say, a good model of, I would say, I will retake the cement kiln, the equipment will grow old. And the kiln, for example, in that case, kind of furnace, for people who are not in the cement production, will get dirty. And I would say dirtier and dirtier because you have dust accumulating into the kiln and so on. And so it means that when you're starting from a clean, fresh kiln, you will have maybe good accuracy with, I would say, the science-based modeling and so on. But then you will see that you will have a drift growing during versus time, because you have this dirty matter which will accumulate into the kiln, and then the consumption of energy will be different and so on, because the kiln will become heavier and heavier. And so in that case, you will have to, I would say, renew the parameters from a part of the model. And then that's the AI part, which will make the job. And once that, after 1 year, you will clean up again this kiln, you will start from fresh, but you can start with the previous parameters from 1 year ago. And then you can adapt this parameterization. But I would say that it's a slight and a continuous drift. So every, let's say that you refresh the parameters every 2 weeks, it will be slight drift into the parameters. And so it's not always the case that you have to change, I would say, the equation from the science-based modeling, but it could be the case. And we could imagine that at one moment we switch to another formulation of the science-based modeling, saying, okay, here there is a kind of fuzzy transition to place, because we will see that we have to go back to the accuracy that we've promised to the customer.
Yeah, good, very, very interesting. So that plays for continual learning in some sense.
Yeah. That's I would say mandatory, because like I said, equipment is growing dirtier, is growing old, and this kind of, you could link that also to the maintenance plan, saying that, okay, when you know that there is a new part of mechanics that has been placed because the previous one has broken, well, you will change the performances of the equipment. And so you have to change maybe some, I would say, parameters, or I would say to at least confidence intervals in that case.
Sorry to interrupt the discussion. As timekeeper, I have to keep the time. Yeah, right. But what I actually could seize this opportunity to say that if you want to ask a question, do not hesitate also to put them in the chat, because if for time reason we cannot answer, we have at least a tracking of it, and we can continue the discussion, because the objective of this event also is to really launch a dynamic of dialogue with certain stakeholders from the enterprise world, if I can say it this way. way. And so please, this is a good way of going about it. Thank you very much, Bob, for your intervention on this first grand challenge. So we're moving to the next one. We're keeping Caroline with us because this is still Ceneiro in charge of it. Mm-hmm. So it's about machine learning based energy prediction, management and optimization towards better energy decision making process. And for this challenge, Caroline will be discussing with Fabien Francis, who is a lead data scientist at Lucy in the Cloud by Macropole. I love this name. Fabien is a data scientist. He has actually, interestingly, a multidisciplinary background in psychology and entrepreneurship as well. I don't know if Fabien is with us.
I'm here.
Yes, there you are. Thank you very much. The floor is to both of you.
Thank you, Anna. Yes, so the second challenge proposed by Ceneiro is to investigate how machine learning can allow to improve energy decision-making process. It should be noted that buildings are in charge of more than 40% of energy consumption and greenhouse gas emissions in the world. So better understanding, managing and controlling energy usage and building performance is really key to try to reduce the energy cost and our consumption. So today I will focus on the energy building performance prediction of the challenge, even if there is also a need in terms of new control strategy for modern power systems. And I would say that, again, as in the first challenge, the data can come from different sources. So we have data from sensors and smart meters from embedded in the buildings. We can have also weather data and forecasting, but also data from numerical simulation of the buildings. So all this data provide valuable information for informed decision making. So the objective is to better understand and monitor the energy performance of buildings at different scales. So for a building, but also for a group of buildings or a city, for example, in order to help the stakeholders. So, for example, building sectors and real estate markets or public authorities to make better decisions in terms of energy. So, the need for transition towards a low carbon economy to limit the effect of climate change does not only mean increased use of renewable energies, but it also implies a more efficient usage of the energy that we have, avoiding waste. So better managing the energy of our buildings using AI goes exactly in this direction. So building energy modeling and forecasting is really a key tool to inform decision making for example, for energy planning, for building renovation, for predictive maintenance and advice to occupants, for example. So there is really a need for this challenge. But as already said, data can come from different sources, and the objective is to see how we can jointly use them for the generation of building energy consumption prediction models. But the problem is that the cost of equipping and monitoring buildings with the appropriate sensor and smart meters is not negligible, and so sufficient historical data may be difficult to to obtain, especially for new buildings or for buildings with newly installed monitoring equipment. So data can also be partially generated by simulation model, but most of the time this numerical simulation have also a cost and are not always sufficiently representative of the problem. So obtaining really sufficient and accurate data can be really a challenge. So to meet this challenge, several technological bricks will be investigated and developed to infer future energy consumption. So of course, we will work on time series forecasting and fault detection and diagnostic methods. But transfer learning has also been identified as a promising technique to develop accurate and reliable building energy prediction models with limited sensor and data, because the idea is to try to take advantage of the rich data and knowledge obtained from a small set of well-equipped buildings, and try to use this knowledge to transfer this knowledge to buildings where we have limited data. So to try to reduce the computational time and the cost of the model that we will train. And also an important point is again the explainability of the provided prediction, to make the prediction more trusted by the end users. So sorry. I will now give the floor to Fabien to give its feedback on this challenge and the relevance to their activities and needs at Lucy in the Cloud. So Fabien.
Thank you, Caroline. About the explainability, that's a very important point that you said, Caroline, since, well, if you want to predict energy consumption, you don't just want to predict that. You want to be able to leverage some factor. You want to be able to reduce the energy consumption. So if you just predict the energy consumption, you will not be able to reduce that. You will just be able to say, okay, now you will consume more, but what's the reason? And to illustrate a bit what you can do about energy prediction, I was going first maybe to show you about one of our customers, Creos, that own and manage electrical network. But right now, the most difficult part for them, it's just to be able to collect all the data by a smart method. That's why we are helping them. Unfortunately, we are not there yet on the AI part. But instead, I was going to present you this case, why this slide about how do you make steel. Because it was a nice proof of concept done in the case with Digital Wallonia for AI. So it's a Tremplin AI that offer company the possibility of developing a proof of concept in collaboration with the service provider. And the service provider was us, Lucy in the Cloud. And so in that case, you can go in the next slide. We will go more deep about just one on the part of the making of the steel. So it was about Driver Internationals that make reed furnace. So the reed furnace, it's one step of the making of the steel, but basically it's a big oven, a very large oven that consumes a lot of energy. And what you want to know, it's how you can reduce the energy consumptions of that oven. And for that, of that oven, of that furnace, what we did is to to collect all the historical data, and also about quality testing, because if they want to be able to reduce the energy consumptions, they want to keep exactly the same quality of their steel. And so for that, we predict the quality of the steel and create a model that is explainable. So we will be able to, like a digital twin, let's say, for the steel, create some simulation about a new steel component, about a new chemical component and a new parameter in the furnace. So we will conserve the quality of the steel, but reducing at the same time the energy temperature. You can go in the next slide. I want to show you also that case because it was done with a little amount of days. We spent 20 or 30 days on that case, and we were able to create that model basically using the cloud. So we push all the data here on Amazon Web Services. We use S3, the data lake, and then we use SageMaker to make the machine learning model, which were a lot of them, a lot of different of them. You can go to the next slide. You can, yeah, thank you. Yeah, and about the result, well, we improve 40% the R square to predict the quality of the steel, but also we were able to still have an explainable model. As we spoke just before on the last one, we use the library SHAP. It's a Python, it's a library that uses Shapley for the Shapley additive explanation. So basically, even if you have a black box model, any black box model, so deep learning, XGBoost, anything like that, you are able to explain that model and to know exactly which variable will be used more by your model. And you will be able to do also the global explainability of your model. So the global explainability, it's okay, your model will use more that variable and that variable, but also the local explainability. Local explainability, it's like for one steel grade, you will be able to say, okay, this variable count way more than that one. And so you will be able, after that, to tune your parameter to be able, okay, can I reduce a bit of that or that, and then maybe at the same time reduce your energy consumption. And so, yeah, that was the goal. And now at the Rever, they have in the research and development lab these tools to be able to create a simulation and to reduce the energy consumption. So let me let's if you have any question, if I wasn't clear, because I'm not sure I was clear, but anyway. That was, and as I say, Caroline, yeah. So Karen, it was more about building like a home and flat, etc. But here, this was also an example that in a building like a furnace in industrial category, you can also reduce the energy consumption as well. And you use the same technique.
Thank you to both of you. Are there any questions either on the case that Caroline described about buildings or in the case that Fabien described with the industrial production furnace? I don't know if that's the right pronunciation. No. Okay. Well, I had maybe a question from a non AI specialist, but what we understood for the reason you described, Caroline, about the difficulty of having data because all these captors and sensors are quite recent technology, you were going to use a transfer learning approach. Mm-hmm. But what are the difficulty of what are the challenges when you use such transfer learning approaches for energy consumption reduction? And I guess that could also be a question for Fabien. Fabien, sorry.
Yeah, I would say that one of the main difficulties for the transfer learning part will be the selection of the good representative and reference building to transfer the knowledge. So I think that we have to work on really properly selecting the reference building for the transfer and assessing the impact of the different building features on the transfer learning performance. So I think that it's one of the difficulties. Another difficulties is also linked not directly only for transfer learning, but for the building performance energy prediction in general. Another difficulty is the impact of the behavior of the occupants of the building, because this will generate a great level of uncertainties on the energy use, and the behavior occupant is not easy to get. So I think that it will be also another point to be investigated in this challenge. Yeah.
And one other challenge, I think, if you want to use transfer learning to predict energy consumption, will be to have kind of the same building, but also a standard about the data engineering part, the feature engineering part of your data. So, and even so, using the same smart meter maybe for the first step, since if you use exactly the same smart meter or that use the same standards, then it will be easier to use that.
Yeah, sure.
Thank you to both of you. Benoit is saying that also if the occupants of the building are trailed, then of course the energy that will be unleashed will be even greater. It makes me think of a talk that Luc Julia did not so long ago in comparing the energy consumption of a machine with the one of a human being, and it was apparently we consume 20 kilowatt, or is it something like this? Or Benoit?
Yes, in fact, you have seen the problem, like you have a building with a lot of sensor and you want to learn on it and then do transfer learning on building with less sensor. Am I right? Huh? That's the point.
Yeah.
But we could see the other way by saying that nowadays a sensor is quite expensive, and with time the cost of the sensor is decreasing. And to have, in some sense, a model which evolves and which can scale. The scalability effect is, I think, something also interesting to see, not only the transfer learning, but also the scalability of the model with the increasing amount of sensors with IoT. Yeah. Don't you think so?
Yeah, I think you are right. Yeah.
And to be sure that the system can scale with the of sensor. Maybe, Francis, you have also an opinion about scalability with sensor?
Yeah, for sure. It's cheaper and cheaper, and it's now embedded everywhere, and especially with the cloud and the possibility and 5G and that kind of technology, you will be able to capture more and more data. So maybe it's not even in the, maybe it's the other way around, since you have historical data with not so much of data, but in the future you have more and more data.
Yeah. It could be a second part of the challenge for the future.
And another one for predicting energy consumption, I think it's that you need also to take into account the behavioral science, how people behave and that kind of things as well. So if you can capture that, in addition of the sensor data, it will be also quite great.
Yeah.
Thank you to both of you. And again, we are here to discuss grand challenges, but we're also always thinking of other challenges that we could have in the future. So that's maybe opening ideas here. Thank you, Fabien. Thank you, Caroline.
Thank you.
We are now moving to our third grand challenge. As Benoit explained, each grand challenge is led by a research center, and this one is led by CETIC, and I see that Xavier Lesage has just joined us. Unfortunately, the enterprise rep couldn't join us in the end, so for those firms that are still in the room, do not hesitate to react to this grand challenge, because the objective again of this exercise today is really to get your feedback on the grand challenges we are working on in the framework of TRAIL. But we have also with Xavier Karim El-Khoury from the University of Louvain, because the idea is to have also PhD students and postdoc working on the challenges that we are going through today. And so Xavier Lesage is researcher at CETIC, and Karim is a postdoc researcher at UC Louvain. The floor is yours. Xavier, you're muted, or you're not muted, but we do not hear you. And I'm not sure if Karim is already in the room.
Yes, Karim is there. Huh? Karim El-Khoury is in the room.
Okay. And actually, I was a bit fast. I said that you were a postdoc, but you're still working towards your PhD.
It's okay. No? It's okay. No.
Yeah,
Yes.
we can
Okay,
hear
we
you.
hear you.
Can you hear us now?
Yes.
Yeah.
Hello. Hello.
Yeah, we hear
We
you.
hear you. Do you have some?
We hear you very well.
You can start.
We are having technical difficulties.
They don't hear us.
Can you hear me?
Yes.
Okay.
Perfect. Thank you. Sorry for
No problem.
Thank you. As you may know, artificial intelligence is a very promising technology, but AI is faced with 4 major problems. 1, access to a limited volume of data. 2, risk of linkage of private information. 3, obstacle related to ethics committee. And 4, trust between different partners in a coalition. The issues of the data sensitivity and user privacy is found mainly in the medical imaging domain. When working with patient data in a hospital or with business dealing with client private information. So there are a lot of possible approaches to manage it. To meet this challenge, we started a collaboration with 5 French-speaking universities here in Belgium with TRAIL. We started with a team of 8 researchers, and now we are 11. The idea is to provide several approaches where AI user, solutions, provider, and other partners keep the privacy and the control of their data. The set of challenges that we face are preventing the linkage of private information, preserving secrecy and staying in the line with the protection rules. Can you switch to the next slide? Thank you. It's very challenging. To develop an effective AI, we need 1, to have high quality of data. 2, to secure data during each operation step, for example, training inference. Manage several sources of data, like to protect the AI models against individual properties.
No, ce l'avevo in cuffia, poi ci ho messo un quarto d'ora a rimetterlo qui su perché la linea dovevo togliere la VPN e tutte queste. Dai, la missione. Ieri, no. Ma io la sapevo già là.
On the next slide, thank you. Yes, thanks. With our team of researchers, we are working on the following solution. Mainly, our solution is based on federated learning, where training is executed where the data is located. Also, we rely on several tools of anonymization to ensure data privacy. In few months, we are going to working with the homomorphic encryption and increase the resilience of our system. Now, I will let Karim, a researcher from your team, give us more details on your results.
Anne-Laure, could you please go to the next slide? Thank you. So thanks, Xavier, for the presentation. So I'll try to present the results that we have so far for Trail. And well, here I see a small screen, maybe a mistake. But the idea is that we have okay, thanks. So the idea is that we would take the example of medical imaging, for example, and federated learning is very useful in the use case of medical imaging because it faces all the challenges that Xavier has presented, and at the same time, it would benefit from being able to collaborate because of the lack of data that are available in hospitals. So we would need to have a secure way to work together, while at the same time trying to take advantage of the lack of data that we have in each hospital. So what we did is we implemented DSAIL here, which is the title of our solution. And what we simulated is several hospitals trying to treat the same problem. For example, here we try to detect breast cancer tissues. And what happens is that we train a network locally in each hospital, in each simulated hospital, and the decisions, the weights of each network are sent to a private server, which is then sent out to decision is then sent back to the hospitals, and the networks are retrained, etc., and several batches can be done. The idea is that all networks are benefiting from the collaboration without actually having to share their initial data. We have very promising results so far, and a question that we are trying to address now is what happens if different hospitals contribute differently. So, for example, a big hospital and a small clinic contribute in the same ecosystem. Does it benefit all partners? And the answer is, for now at least, mainly yes. We can see on the graph on the right. The idea is that all partners will benefit, even those who have contributed with little amounts, or those who have contributed with the most amount of data. For our tool also, our tool is now publicly available on GitHub, and what we also added is a whole hospital file management system. So it's a plug-and-play solution that's available via the Trail Factory, of course, where we can input data, we can anonymize this data, train it locally, split it into different splits into hospitals, and aggregate our weights to have a final decision. This is a summary of our results so far. This is still a work in progress, and we are looking to publish our results as soon as we have some advancements. Thank you.
Thank you, Karim. Thank you, Xavier. I see that there are questions in the chat by Sébastien. So, by Sébastien Jodogne, thank you for joining us. Sébastien asked, as far as the data sharing of medical images is concerned, have you considered using the, and I'm hoping I'm pronouncing that right, ORTHANC open source project that is developed at UC Louvain? The ORTHANC project is currently working on the topic of federated learning using the open source development model as source of trust for hospitals.
I can answer that. So for now, we have not used the ORTHANC tools or open source project, but this is something that 100% we should look into when we are developing. As for now, what we have is in this solution we can have several layers of protection, we will say, and the more the merrier. But the idea is that we are still at the very early phase. But of course, this is something we should look into as soon as possible. Thank you, Sébastien, for the proposition.
Yes, feel free to get in touch with me if you need so. Don't hesitate.
Of course I will.
Thanks.
Any other question on this challenge about privacy preserving? Maybe what are your next step now? What are your ambition to do?
Going to work with other datasets like time series, evaluate several types of aggregation of weight and increase the security, mainly for the adversarial attack. And of course, on the homomorphic encryption. We are going to secure the communication between the partner with this encryption.
Okay, thank you. Thank you very much, Xavier. Thank you, Karim, again. And we are actually early in our timing, so that's always always good. What I can, Sébastien, you have another question.
Yes, just one more. But I'm not sure that the answer has been already asked, but who are the partners of this project from the point of view of the hospitals?
For the moment, it's just a simulation of several hospitals, but in a few months, we are going to try this solution with some partners.
And those partners are already identified, or
yes, still? Yeah. Probably with the CHR of this is possible.
I didn't get you. There was a mute in the sound.
It will be with the hospital of Mons and the new Mons and the prison. Thank you. Thank you.
Okay, thank you.
Thank you very much. Also, do not hesitate if there are, I could tell from Sébastien's question that he had ideas in mind. So also to say that we will put all the information in this presentation, but also contacts and additional documents that will be given to us by participants on the website of the event to continue the discussion on the different challenges. So we now have a long break. It was supposed to be 20 minutes, but it would be 24 minutes. And we gather again at 10:30, and it will be my colleague from Digital Wallonia, Julie de Bergec, who will be moderating that part, even though I will still be, here is Julie, even though I will still be the one managing the presentation. Thank you very much for being there, and see you all very soon. Thank you.
come back. I hope you all hear me. Yes, it seems like everybody is coming back after this this little break. So we're going to start in a minute. Hello, everybody. Welcome back. And I'll start promptly at 10:30. Oh, yeah. Hope you enjoyed a little coffee and a good break. So thank you, Anne-Laure. Thank you, the whole team of Trail, of giving me the opportunity to moderate. I hope you won't regret Anne-Laure, because she was doing such a great job. So I represent, as you can see in my background, Digital Wallonia for AI and the different organizations. And our mission is to promote the adoption of AI in Wallonia for a stronger region. And you can see that Trail obviously is one of a very, very strong pillar. And so I'd like to really applaud today's initiative on bringing our top-notch AI research world with the private sector. And this dialogue today is very important because it really contributes to making our AI expert community stronger in Wallonia, to support the 80,000 companies who may need at one point AI. So let us start right away with the world of weekly supervised machine learning. And there we have the pleasure to welcome Multitel, the Multitel team with Jean-Yves Parfait. And Jean-Yves Parfait is heading the AI team at Multitel. And he will be in tandem with Olivier Dereau, who is the co-founder of Acapella, a very innovative company in digital voices. So the floor is yours.
Thank you, Julie. Is the sound good?
Yes, very good.
Okay, so I proceed. The challenge 5 is a weekly supervised learning. It is not a new problem in the machine learning community. In fact, this challenge is as old as machine learning. Why? But the work has still to be done. And why is not time now, even after dozens of years of research? It's because deep learning offers a new way, new approaches to tackle this challenge. Why doing machine learning on weekly label data is so important? It's because it consumes a lot of the time spent doing AI project development. As the pie chart show, the pie chart comes from a company named Source Cloud, and it is a company providing data annotation services. And I took this pie chart because it corresponds quite well to what we observed during our AI project at Multitel. And a data annotation clinic consume as much as half of the time of AI development project. So it is very costly. Manually labeling the data is very costly, and nowadays even modern AI still rely heavily on manually annotated data sets. It is a problem not only because of cost, but sometimes annotated data sets are scarce, are hard to build, or even impossible to build. Take, for example, when you have to tackle with events that are very rarely observed, it is very difficult to build such a data set. It is also a significant barrier for SMEs versus the bigger company like GAFA, because SMEs lack the firepower or the online services to manually annotate the data. Of course, this pie chart corresponds to what I would say to the cost breakdown corresponding to an average complexity project. So half of the time is consumed for preparing the data. Of course, if you have a project that is dealing with knowledge at the border of the state of the art, then of course you will spend much more time dealing with machine learning engineering. But this is what we can. This is what can be observed for common AI projects. Also, data labeling could be also a real defined problem for some application. For example, robots in open environment. It is impossible to label each item they are likely to recognize in an open environment. It is also not only a problem of functionality, but labeling data. You only label data based on the downstream task, downstream AI task you would like to perform. It's not only it's not always the best way to do. If you want to have a big generalization capabilities, so based on the current approach of supervised learning, model lacks generalization capabilities. The aim of the challenge is to develop AI approaches that drastically reduce the need for label data and demonstrate strong generalization capabilities. I take always a funny example. If you look at kids, if you tell them they never saw a panther, but if you tell the kids, okay, it's like a big cat, it is black. The first time you show them a picture of a panther, the kid will be able to identify the picture as a panther. We are far from there with machine learning. And also, it is not only the challenge. The challenge target is to develop new AI approaches, but we notice that AI approaches are often linked to the weekly machine learning is often linked to the data types they are dealing with. So the idea of the challenge is also to validate them across many data types to have approaches that are as general as possible. What is at stake? It is a significant cost reduction in the development of AI solution, increase the performance of AI in domains where clean or annotated data are not always available, and decrease the competitive disadvantage of SMEs against the bigger company. Also, the challenge will allow local companies to make a better use of the data they actually own. Because usually they own data, but if the data are not stored with the target to do AI, usually when you want to develop AI application on this data, you lack metadata. They are not organized as it should be, and these data are almost useless. So this challenge will allow to make a better use of the data stored in companies. The technical challenge of weekly labeling data is that it is a challenge inside the challenge. We have many competing approaches whose relevance depends on the targeted domain. Many of them are still emerging concept, and it is difficult to have a common ground assessment for these AI approach. Lack of generalization capabilities across various data type, because usually and one given approach is developed, is well advanced on a given data type, but is much less advanced on other data types. In-depth knowledge of the learning algorithms is needed, and it can be linked to the explainability, because the performance of these newly developed approaches are linked to the way you know that in machine learning the first step you do is represent data in a lower dimensional space, and this is something usually you don't want to look at how the data are represented inside the deeper layer of the neural network. So here we will need to definitely have better explainability of the internal process during learning. So
okay.
it's quite...
Jean-Yves, I'm sorry, but
I have to speed up. Okay. So what are possible solutions? We have quite a lot, and some are more common, like active learning, few-shot learning, but some of them are still in their infancy, like grounded learning language. And we could also, for processes that are heavily based on non-physical processes, you have the challenge taken by Grand Challenge 1 could be also an interesting approach. So I will now give the floor to Olivier Dereau from Acapela, who will explain why trying to learn from weekly labeled data is important in speech technology development.
Thank you, Jean-Yves. Yes. So basically, we are active in speech technology, and yes, this is a big challenge for us, because we are developing services and created voices that are adapted to specific customer use case. But this is requiring most of the time lots of hand annotation and also linguistic experts input to modelize the languages or the voices. It took us approximately 6 to 9 months to create a new language, and approximately 3 months for creating a new voice. So that's quite a lot of investment from a company. Next slide, please. So Acapela is very interested by this challenge, because the potential to make an AI solution performing well with little data is very good for us, of course. A good example I have in mind is what we call My Own Voice. My Own Voice is a service we develop to help people diagnosed with speech or language disorder to create their voice, in fact, and to capture the essence of their voice, which is very important for them for preserving their identity. And so in this case, we have very, very little data, and the data are very, very not clean, I would say. So of course, the collaboration with Multitel on this challenge is a key topic for us to improve our competitiveness and improve also our business. That's it for it.
Thank you. Thank you. That was short but brief, but concise. Are there any questions from the audience?
Maybe while people are thinking, I'll ask one. So we understood the Acapela group is active in speech-related issue, but I was wondering whether, as we're here to create links between companies and research, would there be other companies that are interested in this challenge, this research challenge of less labeled data?
Yes, should I answer, Anne-Laure?
Yes, sure, or yeah.
Yes, but virtually, every company, because every company developing AI application need label data so far, because supervised learning is still the dominant approach even in the most AI technologies. So basically every companies developing AI application could be interested into that challenge. The problem is the data types the companies have to handle is not the same from one company to another one. And as I mentioned, nowadays, approaches dealing with weakly labeled data are often linked to data types, and we lack SwissSNF dealing with several data types, and most of the time, we do not have SwissSNF, but everybody could be interested. Every company developing AI could be interested in such approach. But we still have work to do to have a robust and cross data type approach.
I see there's another question for Professor Dutoit. Thierry?
Yes, my question is for Olivier. So Olivier, you mentioned several months for designing new voices, but at least some time ago you were developing voices for handicapped people, and it was faster than several months, no? I mean, there is a way to create voices that are a bit faster, no?
Yes, definitely yes, but we are targeting very natural voices, and so that's why we need that time to develop the voices. Of course, we can create quite quickly new voices, but the quality of the voices is less good compared with the new one.
Okay, great. Thank you.
We still have a few minutes that we can to take some questions or comments. Is there anybody else? Yes, I see Noé. Tits. We don't hear you.
Right, I was muted. Here I am. So yes,
if you can speak very louder,
okay.
Please. Yeah.
Okay, sorry. Yes, yes, it was to react about like the question who else would need like to use weakly supervised learning, so to adapt their product with little labels. So right now I am working at Flowchase. It's a company that do an application to learn English pronunciation. And for example, if we wanted to adapt our technology to several non-native speakers, like for example, French people trying learning English, Spanish people learning English, it would be very useful for us to adapt our models towards with little data on Spanish speakers, English speakers, etc. So that's an example of use case of why it would be interesting. If we want to adapt them in the future to learn several languages, it would be good to adapt like our English solution with not too much data towards the new languages. So it was more a reaction and a response to a use case about why it would be useful for us.
Very good. Are you already working together or not at all?
So we are trying to discuss with Acapella. We met Rémi Cadic recently, and we are, I think, trying to see what could be done, but we'll see in the future how that goes.
Okay, nice. Any last question before we go to the next grand challenge? Well, then I propose we go to the next one. If Anne-Laure doesn't mind. Thank you very much. We will stay with the Multitel team, but I think we're going to another. Jean-Yves will give the floor to Emmanuel Jean. And Emmanuel Jean is also in your team, I believe, working as a research and development engineer. And you're going to speak about trustworthy AI. and in tandem with Delta Tech. And Delta Tech is a high-tech design company and will be represented by Eric Calu, who is the project and business development manager there.
Good morning, everyone.
Good morning. Please go ahead.
Hi, thanks for the introduction. So maybe the next slide. The main objective of this challenge is to build and evaluate a trustworthy AI for different sectors, and especially critical sectors. We want to reduce barriers for Walloon companies wishing to deploy AI solutions in regulated sectors. So the goal is to propose to these companies a set of tool techniques or frameworks leading to the development of trustworthy AI-based systems. So as we know, AI is really at the heart of the digital transformation of companies. And indeed, the industrialization of AI is a crucial issue of industrial and economic competitiveness. The major points that encourage the implementation of this AI-based solution are an increase in efficiency, an optimization of existing products and services, and an improvement on the user experience. However, AI-based systems become increasingly complex and appear as black box, which create mistrust and hinders their adoption by user. So next slide. So the main challenge is to put in place a whole framework for the development of trustworthy AI. Europe has made this challenge one of its priority to differentiate itself from other major competitive markets. But in order to encourage companies to use this technology, we need that this framework offer clear and applicable guidelines. Especially for critical systems, the challenge concerns the crucial question of confidence level that can be place in this technology when used in safety critical applications, and also the compatibility with strict certification requirements that exist in this regulated market. So next. No, previous. Sorry. So in order to tackle these challenges and facilitate the deployment of trustworthy AI-based systems, it is necessary to develop tool techniques and frameworks to develop the certified AI. This AI must be based on the principles of explainability, robustness and safety, and compliance to ethic and legal and regulatory framework. As far as possible, also this tool must also take into account existing regulation or anticipate future regulation of the different sectors, such as data protection of patients in health or regulation of drone in aeronautics. As the first step, we investigate or explain the prediction on a medical image classification task. We use visualization tools such as dimension reduction or silencing map to observe the model behaviors. We also perform some simplification based on surrogate model in order to approximate the model by a simpler and interpretable decision tree model. And the results show that the pneumonia chase X-ray dataset used contains a very strong unwanted bias. For instance, in the figure in the middle, you can see that the prediction of the normal class is based on some artifact in the image, like the presence of chin or some letter, which is artifact that not has taken into account to classify the image. Our works also demonstrate the difficulty to choose XAI methods. So you can see in the right figure the 9 different methods, and we can observe that depending on the method, the visual explanation is not the same. It's why in the second task, we worked on how evaluate and choose a good explainable method, and a paper about this experimental investigation is just submitted to the European Conference of Computer Vision. Here are some tracks for the next stage of the Trust AI Challenge. Concerning explainable AI, it would be interesting to investigate other modalities than image, such as text, speech, or tabular data. And about robustness and safety, which are very important also for critical AI-based system. We would like to investigate the concept of humble AI, where the system tries to recognize and act in situations on which the AI model is less confident on its decision. And this topic is linked to research area linked to anomaly or out of distribution detection and uncertainty quantification. So I let now the floor to Eric Aluf from Delta Tech for its feedback.
Yes, thank you. So the feedback that Delta Tech can give is its experience with respect to the development of some application in different sectors which are quite regulated. So Delta Tech is active in the space market, in the aero market, also in the medical market. We have also a couple of products in the augmented reality for sport application and so on, where we use such AI application. So it's a paradigm between what has been done before and the AI. So with classical algorithmics, we had such rules for the certification and so on. And today we have the feeling that those rules are not applicable anymore. So we have things that are more statistical with respect to what was, let's say, very deterministic with the classical algorithm. And so the certification is something which is very important in order to use AI in such a field of application like space, medical, and so on. We have the feeling that whatever the processing techniques or statisticals, including artificial intelligence, these techniques must be part of a system, and at the end, it's the system that is to be validated and to be certified, and not only the AI part of the system. So it is our feeling that a complete system should not be a fully AI system. So we used to deal with such with certification about software. As you may know, at Delta Tech, we produced a product which is called Delta Offsite. It's a FIFA certified offsite decision dedicated to the video assistance referees, and of course the system has been qualified, has been validated, but as mentioned, as a system and not only the AI part of the system.
Thank you. So, you're finished?
So I don't know if so. What's the interest of Delta Tech in the development of such let's say certification activities in order to have a trusted AI system? And as mentioned, we think that we need to focus on the system itself, and the interest of Delta Tech in putting in place such a qualification process is that it's the purpose of all certification, of course. The interest is to be able to provide evidence to the customers, to the users, that the system which is designed for them fulfills their requirement, and of course fulfills them safely, because if we are taking decision thanks to an application for medical application, of course it has to be safe. If we are using the system for autonomous guidance in aeronautics, for instance, of course it has to be safe. In space, you know that it is quite difficult to modify the system that are launched and so on. We can use AI for data reduction, for instance, and we have to be sure that this system is functional without putting some problems into the systems, into the final application, and propagation of issues and so on. So it's why it is quite important to address the question of the trust and the certification. Yes.
Thank you. Does the multi-team want to react, or anybody else in the audience? Any questions?
Maybe I would add that we can probably put in place or propose things in order to have a way of qualifying or scoring, let's say, a design of an AI component. So we have the feeling that we can maybe define a size of the training database, a minimum size that has to be used in order to receive, let's say, a certification, a minimum size also on the number of tests on the database, so we can do some scoring there. And probably also we know that for the training, virtual or real sample are used to train the system, and one could imagine that the number or the ratio between the virtual and the real samples to be used should be defined in order to have, let's say, a kind of certification.
There's a question from the Multitel team.
Question, a reaction. So yes, indeed, in fact, this new ML approach, we have in fact new development activities such as data collection, data preparation with cleaning, labeling, and so on. And we have also the need to train the model, selecting, specifying, etc. But in existing development assurance standard used for certification, the approach is not data-driven, so they not consider this specificity, this new activity. So there is a need to adapt the current certification procedure and have a kind of certification for the ML activities.
Okay.
Yes, it's a point that we totally agree on. So I can give an example. For instance, for space application, we use FPGA, field programmable component. And a couple of years ago, so those components were one-time programming. And today, all the ECSS standards from ESA are focusing on this one-time programmable component, but we all know that today that those components could be reprogrammed, and today the standards are not adapted. I think it's totally the same approach that for the software standards, either the ECSS, the DO1 or the EN1, they have to be adapted for this new paradigm, of course.
Jean-Yves?
Yes.
Okay. You have a question? Yeah.
Yes. A question for Eric. Yes. If you want to cover the full spectrum of trusted AI, you have many aspects. It starts from data quality to the model itself, explainability, uncertainty, propagation, and so on. For your activities, which aspect is the most important for you?
But I think all is to be addressed so far. So all the uncertainty propagation is something that which is important to address. For instance, today we have in space application, in critical application, we times to times use applications that are less qualified than others, and we use what we call supervising system in order to check that the behavior of the less qualified piece of software or application are doing exactly what they have to do. And if something goes wrong, the supervisor take an action. If, for instance, if you are outside the boundaries of an expected result, the supervising system can take action. And I think that the real challenge also today is to check how we can deal and interact between this system which are supervising activities of other ones that are less qualified. But again, we come to the fact that what is needed is the qualification and the certification of a whole system and not only of a part of the system.
Okay, thank you.
In fact, this is linked to the specific challenge for certification in AI, because ML algorithms are fundamentally stochastic, where classical solutions are essentially deterministic. So this induces new type of error, such as approximation, estimation, optimization error, and they are not properly addressed in the current certification norms.
If I may have a question, it may be a little bit far stretched, but does the future AI Act, the European Union regulation on AI, has a huge impact on what you're working on, or is it far from your bed's table, let's say?
The guidelines, the ethical guidelines, define 7 requirements, and we mainly work on requirements linked to transparency, which in fact is explainability, and the safety, which is linked to uncertainty quantification and robustness of the AI, which is a more technical part than legal aspect and so on.
It's also the same for Delta Tech. Yeah? We are more focusing on the safety aspects of what it is developed. So this is the main focus, yes.
So you are following that closely, it seems like then. Okay. Last few questions. Now we still have a few minutes. Jean-Yves? Or is it your previous hand?
Yes, I left my raised hand, but
okay.
no more questions. Sorry.
Okay, no, it's okay.
Correct my mistake immediately.
Well, then we want our speakers to just give a little closing word, maybe.
We have a sentence from one of our developers that he states that the engineering still makes sense and that natural intelligence should not yet be neglected with respect to the artificial intelligence. And it is something that we have to keep in mind, of course.
Nice to close with such a nice statement. I hope the Trail team won't mind that we move towards, we're a little bit ahead of our time, and that we go to the next speakers. It's okay?
Please.
Yes, okay. Well, thank you very much, the Multitel team, Delta Tech, and Acapela, because now we're moving to Grand Challenge 7, and Grand Challenge 8 will also be presented by Ciris. And so another Centre de Compétences, Thierry Coutelier in particular. And so yeah, you're a senior expert, huh? And if I'm not wrong, on your LinkedIn profile, you call yourself a digital evangelist. I always like this kind of title. Anyway, the header of your Grand Challenge is very complicated, but if I am not wrong, it's about the production environment and making it a safer place, a happier place, and a more efficient place. So I'll let you talk, and then you will be accompanied by Grégory Richling, who is CEO of Silix, and you specialize in engineering for life sciences. We've had the chance to meet several times too, because you're very active in AI. And that's really great. So looking forward to hearing what you have to say.
Thanks, Julie. Can you hear me? It's okay? Okay,
yes.
Great. So could you please go back to the previous slide, Julie? Because as you mentioned, the title is quite big, so maybe it's good to explain it. So it's about interaction with AI, I would say state-of-the-art AI, to reach a zero defect, zero accident, and zero burnout in a production environment or workflow. That's what we are going to cover today. So now you can move to the next slide, and I'm going to give you a brief description before giving the floor to Gregory. So the idea, the objective, the goal is really to develop some new AI methodologies that are going to facilitate and really improve the interaction between, on one hand, machines, robots or cobots, and on the other hand, human operator. The final goal is really to assist them in the execution of daily tasks, okay? So it's not only in the manufacturing environment, it can be in the medical environment and many other environments in the industries. So as a side note, I would say that today Industry 5.0 is defined by the European Commission and really provide a vision that aims beyond efficiency and productivity. It really places the worker and his or her well-being at the center of the production process. And it also uses a set of new technologies to provide prosperity while respecting the resource scarcity. So a production environment in which we have zero defect, zero accident, and zero burnout aims directly in this direction and contribute to this vision of Industry 5.0. Next slide, please. So in this challenge, we have some sub-challenges, I would say, some sub-tasks. One of them would be that we have to combine and process different data coming from a lot of different sources. I would say sensors, historical data, event log. And we have also some data which is really hard to quantify, such as the data which is related to the mental health of the operators. So we can qualify this as a multimodal vision. As soon as we have this data, we also need to make sure that we have algorithms that do really generate real-time added value for those humans, for those machines, for those robots, to make sure that the production workflow is really optimal and that we have this well-being. Another quite important point is that we have to find the best way to communicate and to notify the humans, and to have a really fluent dialogue between the human and the machine. So you know that AI is able to provide recommendation to the human. We know we have to define how we are going to provide those recommendations, but also it's also important to take care about what you just mentioned is natural intelligence, because we also have experts in the field that are able to advise to change the way AI is working, so to train the model with a different perspective and so on. That's what we call human oversight. And finally, it's also about managing a complex network of smart devices in a robust and resilient way. Next slide, please. So what can we develop from an AI point of view? There are some solutions with human-centered AI. There is a lot of literature about this. We have also to explore something in active learning fields. NLP, natural language processing. You already mentioned this point, explainable AI, because if you want to make the model better, you have to understand it. And we can have also some side technologies. As an example, we could also use some parts of DLT, so it's blockchain-like, I would say, in the field of smart robotics. We already have some students working on this, and I can see that one of these students is in the audience. We would like also to simplify some neural networks to execute them locally, to respect some privacy issues and GDPR. And we also would like to trying to not to have a black box, but to divide a large and complex system into some smaller and explainable components. Next slide, please. So now I would like to to give the floor to Gregory, the CEO of CETUS. So thanks a lot, Gregory, for joining this session, accepting your invitation. Maybe you can tell a few words about CETUS and Scilex, which is part of Scilex, before giving us your vision about this challenge. Thanks, Gregory.
Thanks, Terry. Hello to everybody. Yes, CETUS is a small SME created in 2009 and located in Liège. Our job is to integrate and develop production systems to improve customers' production, reliability, and performance. CETUS is a kind of technology integrator. We are about 85 people with a turnover of about 10 million euro, with about 40% in export. The project I would like to present to you, maybe we can switch to the next slide, please, Julie. Thank you. The project is called iLabBot. It's a partnership between an end user, a big pharma company, a robot and AGV manufacturer, a well-known company called Stobli. Also, 2 universities, Namur and Liège, and CETUS as an integrator. The idea or the aim of the project is to develop an autonomous lab assistant which can perform simple and repetitive tasks in full autonomy, working in the same environment as human operators in a safe way. The main functionalities of the solution are as follows. So it can ensure safe human-machine interaction. It ensures also operator detection and safe co-working. The solution can do basic and repetitive task management in full autonomy. It ensures also a mobility within a defined area with automated cartography and detection of the working environment. And it has AI-based functionality like grasping capabilities, for instance, the well-known application called bin picking. The main advantage of the solution is repeatability and traceability of the task. So it can lead to 0 defects and avoid human errors or operator mistakes. Safe co-working, which bring and should lead to 0 accidents. And it ensures also 24 hours a day or 7 days a week, repetitive and boring task management, which should reduce burnout or bore out of the operators. That's what I wanted to say about this application.
Thanks, Gregory. So it's a side project they have at CETUS. It's not a project which is related to ARIAC, but it's just to show that they have side projects that are trying to reach the same objective as the challenge we have. And we can see that there are some really similarities between those projects. As an example, the guy working in the University of Namur is one of the professors working in the ARIAC project.
Exactly.
Yeah. So if you have any question, please feel free to ask them.
Any questions or comments? Thank you very much for your very clear presentation. Anne-Laure invited me also to be a timekeeper. I don't have any work to do, so thank you very much for being so diligent.
I don't know. As Thierry mentioned that there are some researchers that are working on this challenge in the room. Maybe they have questions or thoughts they want to share. I mean, otherwise I always have an outsider question, but one that I could have is that, you know, according to your vision, both Gregory and Thierry, what can AI bring to the human in a production workflow? I mean, if you were to say what would be the main contribution of AI to a human? I mean, you mentioned some keyword there, but if you were to really put one idea in the forefront, what would it be?
From my point of view, AI is a computational technique that can treat a large amount of unstructured data in a much better way and with a lot more efficiency than what a human could do. This allows AI to detect trends, build relations, make selections between various events, and analyze complex situations with help of a speech algorithm. The advantage and potential applications are numerous and most probably still unknown today, since we are still at the beginning of using AI in production workflow. But we can already see interesting application in quality control, safety of machinery, intelligent robotics. All these kind of application bring more comfort to operators and bring more sophisticated and qualitative products. This is my short point of view about this question.
Yeah. This challenge is quite large. Huh? So we have different students working on different perspectives, and yes, I think there is a real added value of using AI in different situations, and maybe I could give you an overview of all the students that are working on this challenge, just to give you a different perspective. So right now we have 6 students, but later, maybe on next year, we will have some more students. So we have, as I told you, we have 2 students, one from UNAMUR and one from University of Brussels, working on swarm robotics. So it's really something related to what Gregory mentioned. So on our side as CIRIS, we are thinking about the way to improve the ways the workflow of cobots in a shop floor. So as you know, you have to deliver some goods from point A to point B, and sometimes you have issues with battery, you have a traffic congestion, you can have people on the pathway, so you have a lot of constraint. So we built with them scenarios, and they are going to simulate this scenario in order to improve the way operators do interact with robots, in this case, in the shop floor. So those are for the 2 first students. We have also a student in Brussels, which is Antonio, and this guy has a good knowledge of the simplification of neural networks. So he was also really concerned by the mental health issue during COVID time. So he told me, I really want to help operators to avoid those mental health issues. And he told me I would like to use my theory to bring some more solutions. So the idea would be at the end to create a personal assistant for operators to guide them, and maybe to support them if they have mental trouble. So it's a mix of action recognition, sentiment analysis, and I really like the point of a cappella, because maybe we can find some ways to collaborate. So it's really a personal assistant in a production environment to help the workers. We have also a student from University of Liège, which is trying to find the link between the process automation and AI. So when you are driving a car, you have some automation, you have some notification, and maybe not all of them are useful. So they're trying to see how AI can improve the way we are notified by automation systems and so on. And finally, we have 2 students, one from UMONS. Right now, he's working on source repository systems, but it can be extended to other type of system, as an example, CRM and maybe ticketing system. And he's trying to extract data to see how developers are interacting with these source repository systems in order to diagnose if a part of the sources is not completely abandoned, if there is not a potential burnout in the developer, if there are more bugs in one specific part of the code, what is the reason? So they are really extracting all the information coming from a GitHub repository to see what is the relation between the human, a group of humans, a teams of developers, and a system, a machine, which is a source repository system. And finally, we have a student in Brussels, and she has a good knowledge in the biomedicine field, and she's using active learning and NLP to be able to assist a person in analyzing scientific articles. She's trying to automate the way we can create an ontology about the links between diseases and genes. So it's a very complex. If you have to do it manually, it can lead to mental overload. So she did it by herself. It was really complex, and she told me, yes, we really have to find a solution. AI is a potential way to solve this. So these are currently all the PhD students that are working on this challenge. But I suppose we will have some others in the next months.
I think that last student is Charlotte. Is that correct?
Yes, exactly.
Yeah, we exchanged with her. Oh, thank you so much. Thanks for answering the question.
Yeah, great to hear that. And what if companies here or present today or not would be in contact with this expertise and all these great projects that they're working on their way? Is that the tool champions? Maybe that's a question to Trail specifically.
Was your question, Julie, how the expertise that Thierry described within the framework of a grand challenge would be shared with potential enterprises? Is that?
Yeah, it was more specifically, I mean, if there's a topic, he mentioned great projects and individual researchers working on all these different projects. If there's a specific topic that's interested by a specific company, can they be in touch?
I guess what one of the work that we're trying to do is to actually, encourage students that are using specific techniques, tools that are not necessarily made by them, but that they use in the framework of their research to become champion of this tool and to make the ecosystem know that they have this knowledge. And this indeed will be shared via the factory, the Trail factory. We are not yet sure how this can be done, so we are going to test in the coming days. And for now, there is very concretely a template that the student feels saying, who he is, who he or she is, what's the tool, and what it can be used for, and then usually an email where he or she can be contacted. So yes, I assume that some of the expertise or topics that Thierry just described could ultimately be turned into a tool that would be shared via the Trail Factory platform. Yeah.
Yeah. That's the idea. The PhD students are going to deliver building blocks that will be made available on the Trail Factory platforms. But if we have some other company in the audience that are able to provide some data sets that could be relevant for this challenge, please do not hesitate to contact us, because we really would like to have some more data sets. And we have some data sharing agreements, so it's really confidential. So please feel free to contact me or to contact the Trail or ARIAC people if we can support you. Okay?
Okay. Great to know. Is there a last question? If you don't mind, I was very interested to hear Grégory mentioned that we are just at the start of AI in production. How? What is the transformational aspect that will radically change that? Make the what revolution will happen to make AI even more present on the production floor?
It's a question for me or to everybody? From my point of view, AI is a kind of breakthrough and a disruptive technology, and it takes time to for such a technology to come into the real world, let's say. Today, production are really very structured and well organized, and if you have a production systems, in general, the line or the machine is developed to produce a single product. And it does always the same task. And in this kind of environment, AI has not so much application. So the production needs to get more variable, more various, and the most various it will be, the more variable it will be, the most AI we will implement into the different production steps. And this will come step by step, I think, in the coming years. Today, except quality control or specific data analysis, there is quite just a few applications. Robots are still very deterministic in their task, and intelligent robotic is not so much used today in production. It will come with the years, and also with the we must keep in mind that most of the people in the industry don't even know what AI is, and people needs to be trained, teach, and young people needs to come with new technologies to influence older people to bring them into real industry, real environment.
Great, thank you. I propose that we move to the next topic and the last grand challenge of today, but we're not moving very far away because we stay, if I'm not wrong, we remain in the production environment and we remain with Thierry, but we are going to say goodbye to Grégory and welcome Baptiste Possepri. And I'm very happy to see him too, because he's representing an AI specialized company, data and AI specialized company, specialized in industry. So also a great ambassador of AI in Wallonia. And the topic, I let you, well, you see, again, it's a very long title, but we remain in manufacturing.
Yeah, thanks. Thanks, Julie. So as you mentioned, this one, you mentioned production, but this one is really dedicated to manufacturing companies. Okay. So this one, so it's the last challenge, the last before the lunchtime. So it's about using some AI solution to achieve first time right and consistent product quality throughout the product development and manufacturing cycle. So what is first time right? So the idea is really to have one new product which is manufactured correctly, so respecting some good quality standards, so as soon as possible, because it can be quite time consuming to have a first right product, and to maintain this quality over time, because it's a long-term. If it's a long-term manufacturing, you can have some issue with machine condition and so on. So we would like to avoid some downtime and some issues with quality. That's the final goal of this challenge. So maybe you can move to, yes, okay, thank you. So as I mentioned, we would like to build some new advanced decision support system to guide operators, but also engineers during two phases, the design, but also the manufacturing cycle. So as I mentioned, we would like to achieve a production with high quality standards and quickly. So maybe you know this concept of manufacturing cycle efficiency, and it's quite important because it's a ratio between the time we spend in the activities that are value added and the ones that are non-value added. So the non-value added activities, these are the manual activities related to moving parts, it's inspecting parts, testing product, and so on. That's what we would like to lower through the use of AI. So if we have some decision support systems that are based on some AI technologies, I think we could significantly reduce the time we spend into those non-added value tasks. Okay, and we can also, of course, increase. We can also lower the quantity of resources that we are going to use in the context of mass production of prototype building. Next slide, please. So we have here some subtasks, some sub-challenges. We have also a lot of different sources of data that we have to take into consideration. We have to link two different types of data. We have some data related to the design and the processing of the product, manufacturing of the product, but we have also data coming from the quality control, because at the end of the production line, we have defect and we need to qualify those defects. So the idea would be to put those two data in relation to be able to diagnose what is the root cause of those defects. Is it about the process parameters or is it about the machine condition? And finally, but we already mentioned this, I think, in the first challenge, it's about the generalization. Even if we have some similarities with challenge 1, we don't specifically deal with simulation here, even if we have a link. But the idea would be to have some systems that are really generic, the most generic as possible, to be sure that we can reuse those building blocks in other manufacturing sectors. Next slide, please. So the solution we could develop, yes, it's about digital twin. We could have digital twin that are completely powered by AI, by machine learning. So we are able to simulate different scenarios before a real production. It will avoid to waste some resource material and so on. It's also about active learning. We would like to use the natural intelligence, the expertise to teach the model in case of divergence. And finally, it's also about explainable and supervised learning, because we would like to be able to not to have a black box, but to explain some behaviors that were inferred by the AI, so that the human is able to continue to play a supervising role and maybe give some piece of advice to train the model better. Next slide, and then I'm going to give the floor to Baptiste Fossepré, CEO of Pepite. Thanks a lot, Baptiste, for joining this discussion. Maybe you can tell a few words about Pepite. Maybe this company is not yet known by some of people in the audience, and give us your vision about this challenge.
Yes, for sure. So thank you very much, Thierry. I hope everybody can hear me properly. And thanks, obviously, for this opportunity to discuss with you on this challenge. Obviously, it is something that tells us a lot in our company, Pepite, and I will come to that point after that. But just to say a few words about Pepite. So it's a spin-off of the University of Liège, incepted in 2002, so it's already 20 years ago. But not to upset anybody in Belgium, I'm myself coming from the University of Louvain, so we definitely want to make sure that we take the best of all possible universities around the table. So our company Pepite is active, obviously, in process optimization. It is something extremely important with a very strong focus on the industry. So AI, this is something that we have been discussing already since the beginning of this morning, can be applied in many different activities, domain sectors. But obviously, we need at a moment in time a given specialization, and the choice that was done by our founders back 20 years ago was really to apply AI to the industry. So the purpose of the company is extremely simple. What we want to do is really to make the industry more efficient. We see these days with the industry, the electricity or gas energy prices by and large that are just skyrocketing, that it just makes sense to be more efficient in whatever the industries are doing. And this is something that we believe can be achieved in a first phase simply by being more efficient. And AI is here to help, obviously, something that was discussed since the beginning of the morning because of the number of data that you can get from a process. And this is obviously the raw material that we need. This is our own crude oil, if I may say, and we need to be really, really efficient in handling that amount of data. So we are working along different axes to, for instance, optimize the energy consumption of a factory, of a plant, to work on the product quality, obviously something which is important here in this case of this grand challenge, but as well to make sure that we can have this consistent quality over time. So then it comes to elements that relate, for instance, to predictive maintenance. So you can see everything comes somehow together. And how are we doing that? It's in a very simple way, is that we have two services as part of our portfolio. We have on the one hand a no-code tool, and this is something extremely important because we want that the tool is used by the maximum number of users into an organization, and we talk here about engineers, but not only, we talk as well about operators that are sitting on the production line. And we have as well a methodology, and it is a point that I will address just after that, which for us is extremely important, because if you want to be successful in adopting AI, you really need to be properly organized and phased in such a way that you do things in the right way. So if we talk about the challenge in itself, of course, it is inspiring because of the elements that I just mentioned. It is directly in our DNA as an organization. We really want to bring tools that can really support engineers, operators to make decisions. So that's really what we stand for. And this is something that we see on a daily basis. We deal with customers around the world, basically in all possible continents, and in a pretty large variety of sectors as well. We deal with customers in chemicals, in cement, in metallurgy, in oil and gas. It's pretty broad actually, and we always see that we always come to a set of similar challenges. And this is what I've been trying to put together on the next slide. So if we might just switch to the next one. It's the only slide I have, but actually it summarizes here what we believe are really the criteria to be really sustainable, to make sure that AI-based solutions are sustainable and scalable. What do we mean by sustainable and scalable? It just means that once people adopt this solution, they adopt them for quite some time. It's not a one-off exercise that we want our customer to do. We want them to make sure that they really embed the use of AI-based solution into their organization, into their processes, into the technology field and technology stack to make sure that they use it in the long term. And scalable as well. Why? Because it is important that once you are able to take care of a given thematic, you can really scale it to other thematics in a very simple way. And this comes from the fact that we give the users the tools and the capability to be autonomous in the way they work. We do not want our customers to call us on a daily basis to get some support from us. We just want them to be autonomous. So the various points that we get there, right, if I would really go to the criteria themselves that we consider as being important to be successful. So it's somehow a kind of list of key success factors that you get there on the slide. The first one is really to focus on measurable impact. So what do I mean? What do I mean by that one? Is really to really focus on the business metrics that you want for the key performance indicators. So what we have on the right-hand side of this image, it's really a set of typical KPIs that we define with our customers. You can read them to improve the throughput of your process, the yield of this process, to improve the product quality, equipment efficiency, to work on predictive maintenance, energy efficiency. We really need to start from that, to really ask ourselves the question, what are we trying to solve? Once we know that, of course, comes the second element, is the fact that you need data to work on that. And this data obviously needs to be made available and to be clean. So that's somehow the beauty of working with process in the industry, is that we get quite a lot of data. So it's not about what we hear very often from our customers, is that they are data rich but information poor. And this is something which is extremely important here, is that we really need to make sure that we can extract information from that data. And so the second bullet point that for us is extremely important is that we really want our customers to follow an appropriate methodology. They should really work one step and advance one step at a time. So what you can see on the bottom side of the slide is the set of stages that we have in our methodology that really support the customer along the journey. And as you can see, it really starts by what we call a digital data diagnostic. This diagnostic actually work together with the customer to analyze the level of maturity that the customer has in the organization. What kind of data do they have? Where is the data coming from? What information could possibly be missing? Or are they handling the data for the time being? So really to have a kind of état des lieux, to have a look at where we stand, and then define along this methodology what is the best opportunity that needs to be tackled in the first phase? Because the opportunity that needs to be tackled in the first phase is the one, if it has a significant impact, that will really make sure that you will be able to scale, again, these AI-based solutions, these tools, to other thematics that you have into the organization. So it's extremely important to focus then on one dedicated problematics, treat it properly, and then Once you know it is handled properly, then move to the next one. And the third bullet point is extremely important. You need to work with your organization. AI is just a technology in the end of the day, but we are human beings, and in a factory, in a plant, you get quite a lot of people involved into the overall production capabilities, and it's clear that you need to make sure that AI data is really put at the center of how people work. So it's really about teamwork, making sure that, for instance, your process or production engineers are extremely close to the operators that are sitting on the floor, to make sure that the information flow is correct between the various teams, to make sure that the proper interaction is brought back to the appropriate levels, and the capability as well needs to be built adequately with time. So 4 bullet points. It's really about the fact that we need to bundle AI, this technology, into solutions that can really be used by people on a daily basis. So that's really something which is extremely important to us, simply because, again, you can have a lot of frameworks that are used by data scientists, but in the end of the day, when it really comes to work on a daily basis on problems that the production and process engineers can face on the production line, they need to be able to access tools that are simple and easy to handle without having necessarily the advanced background that some data scientists might have. And the last bullet point, which is the last element I wanted to bring forward into that very short presentation, is about active learning. It's something, Thierry, that you mentioned beforehand. Obviously, something extremely important, as you can figure out when you are in a production environment. Very often you get people working on the line who get experience and expertise on what's happening because they have been there seeing the machines working for the past 20 years. And sometimes they are just able, because of the noise that they can hear or things that they can see, they are able very often to predict what could go wrong and what could be the problems that they are facing. So this is something where at a moment in time when you really find a way to deal with the data that is coming from the process and can come to recommendations to the operators on what they might have to do, that you need to make sure that these recommendations are properly taking into account all this know-how that you get within the operators, within the people. So really to make sure that the domain knowledge can be as well integrated as much as possible within what the artificial intelligence algorithm, what the models are doing. So this is something for us that obviously is extremely important. Next stage might be the fact that we go to explainable learning, as you mentioned before, Thierry. We are not yet there, but this is clearly something that would be extremely relevant to us to be able to make some progress on that field. So that's it from my side.
Thank you very much.
You're welcome.
Does that close your intervention?
Yes, indeed.
Yes? Okay, well, thank you. Very interesting, like all the other grand challenges. Are there any questions from the audience? Questions, reactions, comments? Well.
If I may. Thank you very much, Baptiste, for this nice presentation. One property on which we try to work in another field, it's a field of video surveillance where we try to put cameras and add cameras. And we have problems to guarantee scalability of the solution, that when we add information, we can scale. So I think I like very much that you are working on criteria for scalability in your AI-based solution, and I want like you to give us some recommendation or some advice in addition to what you said to stress these scalable properties that is very wishable, and to not have one fixed solution, but to have a continuous improvement of your process, thanks to the architecture that you have set, solving a black box problem with showing many examples and learning a black box to do the things is good, but it's not sufficient. You have to scale and to continuously improve the solution. So I like very much that you put that in in the title of your last slide. Maybe if you can expand a little bit the comments that you have done about it, I think it would add value to the team here.
Yeah, for sure. So thank you, Benoit, definitely for your comment and question. So obviously we see scalability at two levels. The first one is in terms of scope, and the second one is in terms of size. So what do I mean here exactly? The scope is actually the type of business problems that we like to address. So typically, and again, here I would refer to a specific case as Pepit as an organization when we serve our customers. We would end up in a factory where typically we would first, as I mentioned, in terms of methodology, address a given thematic, a given problematic. So sometimes we are just addressed by customers because they have a quality problem and they realize that things are not going right. So we support them to make sure that they take control over the tool, as I mentioned, through the fact that it's simple to use, it's relatively straightforward. But what we want to do is just that it's more than giving them the possibility to using the tool. We want them to give them the possibility as well to grow the tool. So what I mean by then is that if, for instance, they focus on the product quality, and they get some results because they really know what are the kind of actions and recommendations they can give them to operators on the shop floor to make sure that they permanently tend to this product quality. If then they realize that there is somewhere else in the organization, someone that, for instance, is challenging the production department on the fact that they might be not necessarily as efficient as they might dream in terms of energy consumption, it is a completely different thematics. What we want in our tool as being scalable is that in the way we have been developing the team capabilities in handling the tool in the first phase, so for instance, handling the product quality, they understand exactly how they should work on the basis of the tool to be able to work on the basis of a different and a new problematics. So again, if I take a second here, problematics such as the one of the energy efficiency, we should support them so that they know what are the key performance indicators, the metrics, the output, and how they can work with all this algorithm that we have into our suite. It's a suite of algorithms that we are compiling, or they can work with them to achieve the objective that they are giving themselves. So this is really in terms of scope, the first dimension, if I want to put it that way, that we
Very
consider.
So I understand you want to give them a methodology that can be applied to different part of the global company. Yeah, thank you.
And the second one, and I will give a short answer on that in terms of scalability, is really then about simply about the question of size. So we have customers, for instance, that have several production lines into one plant. So typically they will address a problem on the first production line. It could well be that the second production line is not exactly the same because equipment has been procured a little bit later. And so also they are making the same product in the end of the day. The process in itself is not exactly the same. So what we want is that they can as well scale it here in terms really of size and push it to the next production line. And ideally, as you can figure out, what of course is our desire always when we talk to customers, not only to push it to the maximum number of production lines that they might have on a given site, but when we have customers that have different sites as well to push it to different plants. And typically we see that we work with multinational companies that actually have operations in Asia, in Europe, and in the US. They have, as I mentioned, similar kind of, they have the same products, but they do not have the same production line. But in the end, what we want is then they develop as well a kind of MLOps problem solution. Is something we didn't discuss about that one here as well. But this is something on which we are working as well, because typically the kind of models that you could develop them, for instance, at the headquarters of the organization or in the digital, call it as you want, department of the organization. And typically a model that you would be able then to deploy and to develop at the headquarters of the organization, then you can push it and deploy it onto all operational sites within the organization. So that's something which is extremely powerful as well.
Okay, thank you on those nice exchanges, and empowering our clients is definitely something that we want. And before we give the final words, the closing words to the co-founder of Trail, le professeur Thierry Dutoit, I'd like to just quickly, if I may, congratulate all these researchers and the leaders of all those grand challenges for the fantastic work that you do and the visibility that you give to all this research through the Trail Institute. And as representative of Digital Wallonia for AI, we are very fortunate of this collaboration, and we wish you lots of success. If I may also just remind you that the AI Week is going to continue until Friday. And there may be, if you are not aware of, there may be an interesting symposium. There's a large AI symposium organized. It's not online. You can go to Digital City in Brussels, organized by l'Ambassade de France, by AI for Belgium, and other organizers. And it will be all about young researchers and companies, bringing them together. So I warmly encourage you to go there. And now, voilà, Thierry Dutoit.
Thank you, Julie.
You're going to close this session.
Thank you, Julie. Julie Leberet. Yes, I would like also to thank all the speakers to this workshop. I think it's been a great workshop on the great challenges of Trail. We've heard a lot of interesting things from companies and from research centers. By the way, I would like to mention that part of the work that is being done on these great challenges is done basically by PhD researchers from universities who spend some of their time, up to 15%, on these great challenges, especially in the framework of the yearly Trail 2 weeks workshops. We've had a first workshop in 2021, no, in 2020 in Tournai, but it was a virtual workshop, of course. And then we've had a physical workshop in Paris-Saclay in 2021, and the next workshop will very probably be in Berlin in 2022, so it's 2 weeks in September. Okay, so if you want further information on our challenges, I invite you to check the website, trail.ac, very simple, trail.ac. We have lots of information there. Also, I invite you to meet us again in Charleroi, because we'll have a meeting on May the 6th at A6K in Charleroi for new exchanges between Trail and enterprises on these challenges. Thank you all. Thank you very much. Have a good day.
Thank you.
Thank you.
Thank you to all.
Thank you. Bye-bye. Bon appétit.
Bye-bye
all. Thank you, everyone.
Thank you.
Bye.
Good afternoon. Bye-bye.
Bientôt.